Hi everybody, it's Mr. D from Mr. D Math, and I'm here working with Bridgeway Academy on the math you need to know. So you're going to see a series of videos from me that show you about math, things that you need to do out in the real world. Hope you find these enjoyable and learn a lot. Mr. D with Mr. D Math, working with Bridgeway Academy. Multiply, multiply, multiply. I bet everybody has seen this kind of a chart before, your multiplication chart. Now, I will tell you this. You want to know your multiplication tables. But here's what I'm going to tell you. You only need to go up to 10 times 10, and I'm going to show you why. But while we're working with why I show you why, is I also want you to think about this. That may not look like a whole lot of fun working on that multiplication chart, but this may look more like fun. What if you could just play with Legos? Legos are actually multiplication pictures. You may not have known that, but every time you pick up a Lego, it's a multiplication picture. Why is that? Well, here we go. Every multiplication problem makes a picture. What kind of picture does it make? It makes a rectangle. Check out this rectangle. My rectangle here is going 3 on the bottom, 4 on the top. You might have a Lego piece like that. Right now you're looking at going, hey, I've got that same Lego piece. Well, guess what? If I counted those up, and I could skip count it either way, I could count by 4s or by 3s. I'm going to do both. If I start here and I count by 4s, notice what I'm doing. I'm going to go here, 4, 8, 12. Hey, 4 times 3 is 12, and you probably knew that already. Watch what's going to happen this way. If I go up this way, I'm going to go 3, 6, 9, 12. So either way you do it, you're going to get the same answer. You can skip count and get there quickly and easily by just making your picture your rectangle. Okay, so let's take something that looks a little more difficult. How about a picture of 12 times 4? Can we make a picture of 12 times 4? And if you remember, when I just started here, I said you only have to know your times tables up to 10. And here we go with a 12. Well, here's what I know. I know everybody here can do 10s and can do 2s. I ask young people all the time, can you count by 2s? They go, sure. 2, 4, 6, 8, 10, 12. Easy enough. Can you count by 10s? Sure, I can count by 10s. 10, 20, 30, 40. Watch this. What if it was just this easy if I make a picture of 4 12s? By the way, do you notice that's a picture of 4 12s? Take a look at it. Every 12 is a 10 and a 2. Well, I just made 4 of them. I made 4 10s and 4 2s. Now you may be thinking to yourself already, wait a minute. I already know what the answer is. If you count it up, you probably do. Take a look. 4 10s, you get 40. 4 2s, you get 8. How about that? 12 times 4 is 48. It's just that easy. Okay? Take a look at this. If I made a picture of 13 times 3, and you say, wait a minute, I'm not supposed to learn my 13s times tables. Well, I'm not even going to say you have to learn your 12s. But what are 13s? Well, you need to know your 10s and 3s. Go ahead, put it in. You can see what's going to happen here. The big dark blue ones are going to get 10s. The little aqua blue ones are going to get 3. Think about what you're going to get. There you go. 3 10s, 3 3s, 30 plus 9 is 39. Now you may be saying, wait a minute, I just did that. I counted it. It was right in my head. That was easy to do. It's just that easy. A picture of 13 times 3. Now you might be saying to yourself, well, I don't know if I can draw that same picture you did. You have those nice, cool little graphics you can use on your computer. Well, you can draw a picture of this yourself. Let's do that. I'm going to show you how to draw a picture of 14 times 6. So think about it. What do I need to make a 14? Well, I'm going to need a 10 and a 4, and I'm going to write 6 of them. Watch this. So I'm going to come in here and I'm going to make some 10s. How many did I need? Well, I need 14. Every time I do that, it's a 10 and a 4. Look at this. I'm going to make my rectangle. Here's my rectangle. What's each one of these? Well, they're all going to be 14s. And I'm just going to come in and I'm going to draw them in. And you're going to see this is really quick and really easy to do. And you could do this as well. Every time down here, I have a 10 and 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 a 10. I'm going to have 6 10s. And I'm also going to have 6 4s. So when I come in and I write all of my 4s in here, look at that. I can count it up. What do I know about this? Well, here's what I know about this rectangle. My rectangle, if I look, is going to be 14 tall. How did I do that? Well, I did 10 plus 4 is 14. And going across down here on the bottom is going to be 6 going across. Well, we can go in and we can work this out now. How do I know? Well, it's simple enough. If I count all of my 10s up, which is easy to do, 10, 20, 30, 40, 50, 60, I know I've got 60 already. Now, you're going to need to know something about 4 times 6, or maybe you can just skip count and do 4, 8, 12, 16, 20, 24. Easy enough if I add them together. Ta-da, there's my 84. And guess what 14 times 6 is? You guessed it. 14 times 6 is 84. It's just like that. Now, you may say, Mr. D, I don't have time to draw rectangles all day long every time I'm trying to do a multiplication problem, especially if it gets big. What do you do then? Well, let's take a look at it and see if there's a quick way to write it down. we're going to use something called the distributive property. Now watch what's going to happen. I'm going to leave my picture here, and you're going to see the same numbers, 24 and 60, doing it another way where you don't have to draw a picture at all. But if you can think about the picture, that's awesome. Let's check this out. 14 to me is what? Well, it's 10 plus 4. And then what do I need? Well, I'm supposed to multiply it by 6. So instead of doing 14 times 6, where you're going to have to do it, working it out, writing it down, watch what I'm going to do. Quick and easy. I'm going to go just like this. I'm going to make sure that the 6 multiplies both the 4 and the 10. And watch what happens when I do this. Look at the numbers I'm going to get. Because if I start this way, 6 times 4 is, and you guessed it, 6 times 4. We just had it. There's our 24 again. Now what do I need to do next? Well, the next thing I need to do is go from the 6 over to the 10. Do you notice? It's 6 10s and 6 4s. 6 times 14. Well, that looks pretty easy now. Why? Well, because I know this, that 6 times 10 is 60, and every time I see a plus sign up on the top, as you see right here, all I'm going to do is bring that plus sign down to the bottom, and then I'm going to add my two numbers together, and here we go again. My 60, my 24, there they are. There's the 60, there's the 24. 60 plus 24 is 84, and just like that, I went in and I did multiplication, quick and easy. Okay, well, does that work with bigger numbers? Absolutely. Now in this video, we're just going to work with a 2-digit number times a 1-digit number, but in upcoming videos, I'll show you how to do even bigger numbers. We're going to multiply 23 times 7. Now, watch how easy this is. I don't think of 23 times 7, I think of 23 like a 20 plus a 3 multiplied by 7, and all I have to do is make sure that both the 20 and the 3 are both being multiplied by 7, because this is what it says to do. 7 20s, 7 3s. You might be thinking that already, going, wow, I can actually do this. 3 times 7. Well, do you need to count it? You can count it either way. 7, 14, 21, or count by 3s. 3, 6, 9, 12, 15, 18, 21. You can do it that way too. But 3 times 7 is 21. By the way, if you can memorize 3 times 7 is 21, there's very few things to memorize in math. However, this is one of the big things you'll want to memorize. Now watch this. What if I have to do 7 times 20? Well, 7 times 20 is just 7 times 2 with a 0. Really? Really? 7 times 2 is 14. Let's put a 0 on there, and there we go. Plus sign in the middle. 140 plus 21, 140, 50, 60, and a 1 is going to give me 161, and just like that, I've got my answer. 23 times 7 is 161. Hope you can do it that fast too. Let's take a look at one more. What happens if it gets even bigger? 45 times 9. Oh my goodness, I have to do 45 times 9? Absolutely. Let's do 45 times 9. Here it comes. To do 45 times 9, we're simply going to come in and go 40 plus 5 multiplied by 9, just like we've been doing before. I could make a rectangle out of this, but this is a lot faster this way. Watch what's going to happen. I'm going to multiply 9 times 5. And if you count by 5s, you can see quick and easy, or just know that 9 times 5 is 45. And then I'm going to come over here and do 9 times 4. Well, 9 times 4 is just 1 9 less, or 36, but it's going to have a 0. Okay, let's count it up. 360, 36 with the 0, 360, oh look, 70, 80, 90, another 100. Oh, I'm going to have 400 with a 5 left over, 405. By the way, if you want to just take the two numbers and write them down and add them really quick, feel free. Look what's going to happen. 6 and 4, there's a 10, and there we go. I've got 405. I've got the same answer that way. I just went across adding it like that. So now you've seen how to go in and work with using what we call the distributive property to work with multiplication. And there you see the distributive property. It's something we use in algebra. We use it quite often. I hope you find it useful and quick and easy when you're multiplying now, that you can do things in your head. Remember, make a picture of a rectangle. From the rectangle, you can actually use the distributive property, because that's all it is. We're using the distributive property, which came from pictures of rectangles. Get your Legos out and time to play.